All right, so I'll go through this little small video for 2015 paper. We are in fact Unit 1, 2015 paper. We'll specifically be looking at Module 3, Natural Resources. Now, question 5A, we have to list 3 types of natural resources other than beaches that can be found in the Caribbean. Now, that's actually very simple. As a matter of fact, we have forest cover here, forest, tropical forest. Why would I say forest? Because many of the vegetation found in the Caribbean can be used for medicinal purposes and also for consumption, or we even utilize the forest for the purpose of building materials. But that they just simply listed in the exam, right? So forest. We also have aggregate, right? For example, now this would not be the same throughout the entirety of the Caribbean, but we must bear in mind we are generalizing here. All right, Caribbean countries actually possess aggregate. Now, many of these Caribbean countries are in fact were volcanically created, as a matter of fact, and the rock type is in fact very significant. All right, so you have forest, we have aggregate. I'm going to highlight something which is ubiquitous here. Ubiquitous resource is in fact like solar energy and even wind energy. All right, solar and even wind energy. And the reason why I'm saying that is because they are termed as inexhaustible forms of energy. Yes, the Caribbean receives an abundance of solar radiation on a daily basis, regardless of the wet or the dry season. In terms of wind energy, the Caribbean country experiences the northeast trade winds. And that is in fact a dominant wind pattern which influences, or it's a dominant weather system which influences the Caribbean. One of the dominant weather systems which influences the Caribbean, and that is also very significant as well. Okay, we also have oil and natural gas, petroleum, crude oil and natural gas. There are many different types of resources found in the Caribbean here as well. Okay. All right. Now, part B, figure 5 shows the mean annual beach width, right, for selected beaches in Antigua, all right, from 1992 to the year 1999. Carefully examine figure 5 and answer the questions that follow. Now, students, when we talk about the term beach, right, geography students should actually appreciate the term beach. That is referring to the deposition of sand, which exists in close proximity to the coast. All right. Now, if the beach width is narrowing and becoming narrower, all right, if the beach width is in fact becoming narrower, all right, we must bear in mind that that area is highly subjected to erosion as time progresses. But if the beach width is in fact becoming thicker, or I should say broader, all right, that means deposition is dominant. Keep that in mind for me, please. I'm going to show you something very quickly. All right, now I want to look at this very carefully, right? Assuming this area in green is in fact the area of land, all right? Assuming this is land here. Okay, keep that in mind for me. This is the land, and this outer region is the sea. Okay, this whole region here is roughly the sea. Now, if I'm talking about sand, right? Deposition of sand, I said that is actually associated with the beach. All right, a beach is in fact a coastal feature influenced by deposition of sand, influenced largely by wave activity, which actually results in these features to be observed. Now, this is what you call an aerial view. All right, so this here is indicative of the beach. This region in blue is called the bay, and we have the land. All right, so keep that in mind for me, please. Now, if I'm telling you that this area, this little region here, where we have the beach, this region here, is actually getting smaller or becoming narrowed. All right, if I'm saying that region here is becoming narrowed, obviously that would mean that the area is being subjected to erosion. But if I were to tell you the beach increases, all right, this area increases in thickness, all right, that means you have deposition taking place. So what I'm trying to say is that as the beach width narrows, all right, you will have more erosion taking place. As the beach width increases, all right, or becomes broader, you actually have more deposition taking place. Keep that in mind for me, please. So let us focus on the question we have here, the mean annual beach width, right? For Dickens Bay A, Dickens Bay B, Crab Hill Bay, Half Moon Bay, right? Look at the image. You can pause the video if you have to. Now, the first part of the question says to estimate the average annual rate of change. Average annual rate of change of the beach width at Dickens Bay A over the period of 1992 to 1999. All right, you have to show your working and represent it in the form of meters per year and show all the working. Okay, let's go through this quickly. So we are talking about the average annual rate of change of Dickens Beach, Dickens Bay A, beach width that is. So if you were to look carefully, right, obviously we know the time frame is at the base, right? We have from 1992, which is here, and if you'll see my cursor, yeah, go straight up, all the way down to 1999. All right, this is Dickens Bay A. Dickens Bay is, in fact, if you look at the key, this is the round one, so we're talking about this region here. In the year 1992, it was at 22 meters. But in the year 1999, all right, if you use a ruler, if you have to, just in case, all right, in the year 1999, it actually went to an estimated, hang on 1 minute, I'm looking at the center of the board, all right? It averaged at an estimated, I am seeing here, roughly 8. I'm seeing here roughly 8, all right? So in the year 1990, it dropped to 8. So from 22 meters, it dropped to 8 meters in the year 1999. All right, let's go through quickly. Oh, I forgot to mention the time period. The time period is actually very important. From 92 to the year 99, that is 7 years. If we start from here, 93 will be 1, 94 2, 95 3, 96 4, 97 5, 98, 6, and 99 is 7. Or you could just simply say 99 minus 92. All right, you get 7 years. So we are dealing with Dickens. Sorry, did I say Dickens? I mean Dickinson. I believe it's Dickinson's Bay. My bad. If I've been saying the wrong thing all the time, sorry about that. All right. So we're talking a period of 1992 to the year 1999, which is in fact 7 years. All right. And we also have, for the year 1992, the actual width was in fact 23 meters. Good. I'm sorry, I meant 22 meters. And the year 1999, it went down to 8 meters. All right. Okay, so let us calculate the entire thing now. So the actual change was in fact 22 minus 8 all over a period of 7 years, which is in fact 22 minus 8. Break the maths. You will actually get 14, all right, over 7 years, okay, which is the same thing as saying 2, if you cancel 7 to 7, 1, 7 to 14 is 2 meters for every 1 year, all right, so it is approximately, if you want to compare approximate sign, 2 meters per year. That is the average rate of change in terms of the actual bay, the beach width, sorry. So from what we can observe, all right, for Dickinson Bay, all right, A, all right, from 22 to 8, there was a decline. So the average rate of decline was in fact 2 meters per year. All right, assuming that part 2 now, right, assuming that the trend in beach width at Dickinson Bay A remains the same. Predict the width, all right, of the beach at Dickinson Bay A in the year 2002. Let us see. Look how simple this is, right? So in the year 1999, it was approximately 8 meters. That's the beach width. If you know the average rate is 2 meters being reduced every year, in the year 2000, it will be 6. In the year 2001, it would actually be 6 minus 2, which is 4. In the year 2002, which will be 4 minus 2, which is 2. So in the year 2002, it can be estimated that the actual beach width would be 2 meters. All right. All right, part 3. Let us outline 4 problems that may be caused by the trend of beach width for Dickinson Bay A, illustrated in Figure 5. Now, first and foremost, we have to understand that one of the most significant trends associated here, well, the trend associated here, sorry, is in fact a narrowed beach width. A narrowed beach width would actually be associated with several problems. Number one, the swash or the movement of water, all right, which approaches the land, would actually have a greater degree of erosive effect. It will actually contribute to more erosion. Secondly, there would in fact be a greater a greater loss, all right, in terms of sand, and that would be attributed to a greater degree of instability along the coast, right? Which means that the actual headlands or these peripheral regions would in fact be greatly compromised or even undercut by wave activity to a larger extent. Thirdly, we must understand that there will be a greater area which will be affected by salt water sweeping inland, which can actually contribute to a large extent. It can actually contribute to an increase in the salinity of the in the salinity of the soils. All right. Now, if this is happening, right, if there are in fact perhaps some potential agricultural area in close proximity to the coast, right, those areas can potentially be subjected to a greater degree of soil salinization, right, because of salt water sweeping further inland. All right. Apart from the obvious, which is that the landmass itself would be becoming smaller or somewhat, I should say, shrinking, given the fact that you have more water and more volume of water in contact with the land. All right, we must also bear in mind the effect would also be associated with the fourth point, which is a potential saltwater intrusion. All right, if you have that buffering capacity, which is the sediments along the beach, that is the beach itself being eroded, that means you have a greater degree of salt water in proximity to the landmass itself, which would simply mean that you'll have more volume of water in contact with the land, right, occupying a greater surface area. And given the fact there is undercutting taking place, we must understand also that salt water, all right, can actually tend to permeate into the ground, all right, because there's no longer that buffer of sand to actually keep the waves or even the water level further away from the landmass itself. And the salt water can actually simply permeate in the ground at a much faster rate, all right, and this would result in saltwater contaminate existing groundwater reserves. All right, so saltwater intrusion can potentially happen as well. Okay. All right, this last one very quickly. Last question for this particular last part for this particular question. Compare the use of forest resources by indigenous people and commercial operations, and your answer include 2 points. All right. Now, first and foremost, we have to understand indigenous people would simply they will utilize, they will consumptively they will consume, resources. All right, they will engage upon consumptive use of forest cover, but it will be over a small range. If there is in fact any level of clearance, it will be in a relatively small area. Yes, indigenous people practice slash and burn, but it actually was associated with a small degree of clearance. Whereas commercial operators and the operations would surround the activities basically would encourage large expanses of land to be degraded, right? Either through the use of machinery or either through the use of fires, all right? Also, we must bear in mind that the second point is that commercial operations are associated with activities which are solely based upon profitability, all right? Hence the reason why there is so much of exploitation, all right, of said resources. In this case, we are referring to forests. All right, whereas indigenous people would in fact utilize their surrounding vegetation, all right, primarily for domestic needs or their own individual purpose. And it is not for profitability, but it is mainly for the purpose of survival. Traditional tribal or indigenous persons will have a very intrinsic value upon the forest, hence they tend to maintain, right, their surrounding vegetation rather than technically destroy it, right, for a paltry price. Okay. All right. So for question number 6, we have to define the term non-consumptive use as it relates to the use of natural resources. And we should bear in mind that non-consumptive use of natural resources can basically is in fact associated with the use which does not involve any level of extraction or exploitation or physical removal of said resources from the natural environment. All right. Moving in quickly into part B, Figure 6 illustrates the trend in the amount of crude oil transported by sea and the amount of oil spilled by tankers worldwide from 1970 to the year 2010. Carefully examine Figure 6 and answer the questions that follow. We are seeing here, on the right-hand side, we are actually seeing the amount of oil spilled in tons, all right? We are also seeing on the left-hand side, the seaborne oil trade, which is in millions of tons, all right? And we are also seeing the seaborne oil trade, which is in fact the black dot, the black squares, and the white squares are referring to the amount of oil spilled. All right, so take a little observational note. You can pause the video if you have to. All right, look at that particular graph for me, please. Now, in which decade did the seaborne oil trade decline? Now, students did ask you for a decade. Now, seaborne oil trade, if you go back up in the screen here, the seaborne oil trade is black dots. And the decade is from the year 1980 to the year 1990. So from the year 1980 to the year 1990, there was a decline in the seaborne oil trade. All right. All right. The second part of the question is state the trend in the seaborne oil trade and the trend in the amount of oil spilled as illustrated in Figure 6. All right. So for the seaborne oil trade, generally from the year 1970 to the year 2010, there was an overall increase. All right, in that particular trade. All right. With the exception of the fact that there was a decade-long decline from 1980 to 1990 in terms of the actual trade itself. All right, whereas the amount of oil spilled, all right, actually showed a very sharp decline, all right, from 1970 all the way down to the year 2010, right, where the year 2010 and 2000 to the year 2010 was in fact a decade-long plateau, right? At the lowest levels, especially as it relates to the amount of, in terms of the amount of tons of oils that were in fact spilled. All right, so keep that in mind for me, please. All right, so the next part of the question is geographical and demographical factors could give rise to trend in the seaborne oil trade, while technological factors could give rise to the trend in the amount of oil spilled. Now we have to explain this statement. Whenever we are talking about geographical and demographical factors, geography has to do with the actual location. So geographical factors revolve around location. Demographic factors revolve around the population increase or population change. Now, how could demographic and geographical factors contribute to the, give rise to the trend in the seaborne oil trade? Let's see that quickly. Now, in terms of the geographical factors being influential in terms of the general increase in the seaborne oil trade, it could be that there were in fact more and more geographical locations where that oil or the reserve of oil, right, or reserves of oil rather, were in fact found. All right, and of course they were exploited. Okay. In terms of demographical factors or demographic factors, we can understand that as the population increases, all right, there will be greater demands upon the consumption of energy. And this is in fact one of the resources which can be utilized as a major source of energy, primarily in developing and developed world, all right, where it can be combusted to produce electricity and by extension other levels of productivity. So as the population increases, there will be increases demands upon the existing services as a matter of fact. All right. Okay, let's go through quickly. Now the second part of the question is that while technological factors could give rise to the trend in the amount of oil spilled. All right, so let us see that quickly. From the graph, we saw that the amount of oil spill declined from a roughly, say, 2,750, 2,750 from the 1970 all the way down to a very low year, like say roughly about 100 average tons. All right, this decline could have been owed to technological factors. Why? Because with the progression of time, technology improves. So does its efficiency. And the improvement in the technology and its efficiency would actually contribute to a much more pronounced or a better means of extraction of said resources. All right, which could result in limited or little to no wastage. All right, okay. Now, part C, they said, part one, they actually said here, name the name the international environmental and conservation agreement which would apply to the activities illustrated in figure 6. Now, students, when we are talking about seaborne oil trade and oil trade, especially in coastal areas and whatnot, you have to understand this is in fact something very unique. And this has to do with exportation, imports, and demands and supplies and stuff like that. However, the actual international environmental and conservation agreement would in fact be MAPOL. All right, the Marine Pollution Convention that is related to using best practices and even also utilizing at some point different technological inputs which can actually help to remediate the effects of pollution. Anyway, so that's the name it. So just the International Environmental and Conservation Agreement would actually be MAPOL Convention, MARPOL. Good. Now we have to outline now 4 principles of the agreement, right? 4 principles of the agreement identified in C1 and allowed to be effective. Now, first and foremost, in terms of the first principle, it should be noted that all countries, right, all countries which happen to be signatories of this particular treaty or this particular agreement, right, they basically must in fact follow or be in compliance with certain requirements, all right, which technically mean that on a national level, all right, every single country must have measures and precautions in place, right, to ensure that the existing vessels which simply traverse their waters, all right, are not in fact polluting the environment. That is one. Two, the objective basically of this particular, well, one of the principles is simply to minimize or to reduce the effects of oil, which is primarily from extraction as well as transportation, all right, as well as other dumping of solid waste materials in and around the periphery of the environment. Thirdly, this particular agreement, right, takes into consideration accidental as well as deliberate, right, well, spills or dispersal or activities which can contribute to negative effects upon the natural environment, all right, upon the marine environment specifically. So it focuses upon the direct and the indirect as well as the accidental and or deliberate effects of marine pollution. And last but not least, we also must consider this is a very holistic approach which doesn't only take into consideration noxious substances being transported or even sewage for that matter, but also take in consideration atmospheric pollution from vessels or ships which can actually descend upon the surface of the water. All right, because vessels simply are powered by fossil fuels, and what happens is that they eventually settle over the surface of the water, which can eventually, because of atmospheric fallout, and can eventually affect the acidity of the water, all right, or the surrounding environment. All right, so it takes into consideration even atmospheric pollution as well, as a matter of fact, of those vessels which simply traverse the seas. So this is more of a holistic point of view or holistic perspective. All right. Now, Part D suggests one way in which the activities illustrated in Figure 6 may have an impact upon the biodiversity and explain why the effects of this impact may likely to be minimal during the period of 1990 to the year 2010. All right, we have to understand within that 20-year period of 1990 to the year 2010, we have to understand that there were in fact still human disturbances. Biodiversity disturbances as it relates to the oil spills would actually contribute to the death of animals because oil is a very invasive thing, especially in a fluvial environment where it simply spreads. So it will still cause a significant threat upon the biodiversity given the amount of oil being spilled. For instance, in the year 1990, it was roughly a little less than approximately 400 tons, right, of oil being spilled for that particular year, which is contrastly lower than previous years, previous decades, right? However, within that period of 1990 to year 2010, the last 10-year gap, there would be a minimal impact upon biodiversity primarily within the last 10 years from 2000 to the year 2010, because we would have seen that the actual amount of oil being spilled, right, was in fact held at its minimum from the graph. All right. So what I'm trying to say is that within that particular period, all right, there will be a significant decline in terms of biodiversity disturbances. We are not saying the disturbances would be non-existent. We are just saying there will be a significant decline in it. All right. Because the seaborne oil trade is still existing, as you can see from the graph, the black line going up. That's why the fact of the matter, technological innovations have contributed to a stark reduction in terms of the amount of oil being spilled, which will actually minimize the amount of disturbances upon the marine environment or the diversity. All right, the entire marine ecosystem will in fact not be as compromised as the previous years. All right, so that's basically it, and this will actually take us down to this is in fact the last question. All right, in the year 2015 paper. I hope it was actually beneficial. Anybody have any questions? Feel free to let me know. All right, you'll keep good. Bye bye.